In March of 2025, a team of astronomers pointed a telescope in the Chilean desert at the single most distant galaxy ever confirmed to exist, a galaxy so far away its light has been traveling for 13.5 billion years just to reach us, expecting to find almost nothing there at all. Instead, they found oxygen, not a trace amount. Roughly 10 times more oxygen than their own model said should be physically possible at that point in the universe's history. One of the lead researchers on the discovery said in his own words that he was astonished. Another called the result genuinely mind-boggling. This is the real story of JWST Z1400, the most distant galaxy humanity has ever found. Why finding oxygen inside it broke a piece of cosmological math that astronomers had relied on for years, and what it means for the broader, ongoing crisis, and how scientists think the early universe actually came together. If you want more real discoveries explained without the exaggeration, subscribe now, because this specific mystery is still very much unresolved. To understand why finding oxygen in a single galaxy could genuinely rattle cosmologists, you first have to understand exactly what oxygen actually represents in this context, because it isn't simply another chemical element sitting on a periodic table. In the earliest moments after the Big Bang, the universe contained essentially nothing but hydrogen, helium, and a trace amount of lithium. Every heavier element that exists today, astronomers refer to anything past helium as a metal, regardless of whether it's actually a metal in the everyday sense, had to be manufactured somewhere. And the only place capable of doing that manufacturing is inside a star. Stars fuse lighter elements into heavier ones over the course of their lives, and when massive stars eventually die, they explode as supernovae, scattering those newly forged heavier elements out into surrounding space, where they eventually become the raw material for an entirely new generation of stars and planets. Oxygen specifically requires that complete cycle to have already happened at least once, an entire generation of massive stars living out their full lifespans and then dying before it can appear anywhere in meaningful quantities. That basic fact is what makes JWST Z1400 such a genuine problem for existing cosmological models. This galaxy was first identified using Webb's near-infrared camera as part of the JWST Advanced Deep Extragalactic Survey, an ongoing program specifically designed to hunt for the earliest galaxies in the observable universe. Follow-up spectroscopic analysis placed the galaxy at a redshift of 1432, corresponding to a period less than 300 million years after the Big Bang itself, making it, at the time of its announcement, the most distant confirmed galaxy ever observed by humanity, roughly 100 million years earlier than the previous record holder. Its light has been traveling for approximately 4 billion years to reach Earth, meaning Webb isn't just photographing a distant object, it's looking directly into an era of cosmic history astronomers call cosmic dawn, the period when the very first stars and galaxies were still in the process of forming. The oxygen detection wasn't the only surprising feature of this galaxy either. When astronomers first characterized JWST Z1400 using Webb's near-infrared camera, they noticed its light appeared considerably redder than theoretical models predicted for a galaxy at this specific distance and age. Researchers determined that this unexpected reddening was being caused by dust within the galaxy itself, physically scattering and absorbing shorter wavelengths of light before it could escape. That detail matters because dust, just like oxygen, isn't something the early universe started out with. It has to be manufactured by stars and then distributed through a galaxy over time, meaning the presence of significant dust content adds yet another independent line of evidence supporting the same broader conclusion. The oxygen detection pointed toward that this galaxy had already been through multiple generations of star formation and stellar death, long before the light currently reaching Webb's mirror ever left it. If a story built on real, peer-reviewed astrophysics published in nature-affiliated journals is the kind of thing you want more of, drop a like on this video right now. It genuinely helps this content reach more people who'd get value out of it. There's a specific technical achievement buried inside this discovery that's worth appreciating on its own, because detecting anything at all from a galaxy this distant pushes Webb's instruments right up against the edge of what they were physically designed to accomplish. Jake Helton's analysis specifically involved Webb's mid-infrared instrument, or MIRI, which managed to detect the galaxy at longer wavelengths than Webb's primary near-infrared cameras typically capture, a genuinely remarkable achievement given the sheer distance involved. Because the galaxy's light has been stretched so dramatically by the expansion of the universe over billions of years, light that was originally emitted in the ordinary visible light range has been shifted entirely out of reach of Webb's near-infrared instruments by the time it finally reaches us, only becoming detectable at the longer wavelengths MIRI is specifically built to capture. When Helton compared the brightness MIRI actually recorded against what would have been expected purely by extrapolating from Webb's other instruments, The source came out brighter than that extrapolation predicted, itself a strong indicator of exactly the kind of bright emission lines from ionized hydrogen and oxygen that the subsequent ALMA observations went on to confirm directly. Once Webb identified the galaxy and confirmed its extraordinary distance, two separate research teams turned to a different instrument entirely to study it further: the Atacama Large Millimeter Submillimeter Array, known as ALMA, a network of radio dishes spread across Chile's high desert, specifically capable of detecting certain chemical signatures that Webb's own instruments aren't built to capture directly. What both teams found, published in separate studies in the Astrophysical Journal and Astronomy and Astrophysics, was a clear, unambiguous detection of oxygen within the galaxy, at a concentration researchers calculated to be roughly 10 times higher than what their existing models predicted should be possible for a galaxy existing at this exact point in the universe's timeline. The reactions from the scientists directly involved say a lot about how seriously this result actually rattled the field. Stefano Carniani, an astronomer at the Scuola Normale Superiore in Pisa and lead author of one of the two studies, described himself as astonished by the unexpected results, adding that the finding opened up an entirely new view on the earliest phases of galaxy evolution. Sander Skous, a doctoral candidate at Leiden Observatory and lead author of the second study, put the significance in especially vivid terms, comparing the discovery to finding a fully grown adolescent in a place where scientists had only ever expected to find infants. George Reek, a Regents Professor of Astronomy at the University of Arizona and senior author on a separate analysis of the same galaxy, was similarly blunt, describing the complicated cycle required to produce this much oxygen this early, as, in his own words, genuinely mind-boggling. If you found this as fascinating as I did while researching it, drop a comment and let me know. It genuinely helps me figure out what to cover next. It's worth appreciating just how quickly this specific record has been broken and rebroken, because it illustrates how rapidly Webb has been rewriting the map of the earliest observable universe since it began science operations. Before JWST Z14-0 was confirmed, the previous record holder for most distant known galaxy had itself only been confirmed a relatively short time earlier, and JWST Z14-0 pushed that boundary back by roughly 100 million additional years toward the literal beginning of cosmic time. That pattern, one record quickly giving way to an even more extreme discovery, has repeated itself throughout Webb's mission so far, a direct reflection of just how much observational capability this specific telescope added compared to everything that came before it. Each time the distance record gets broken, researchers effectively get a slightly earlier, slightly more primitive snapshot of the universe to study directly. And so far, every one of those snapshots has continued turning up unexpectedly developed, unexpectedly mature structures rather than the faint, barely formed protogalaxies older models predicted astronomers would eventually find as they pushed the observable boundary further back toward the Big Bang itself. Here's why that reaction matters so much scientifically, rather than just being a colorful way of expressing surprise. For JADE's GS-Z14-0 to contain the amount of oxygen actually detected, the galaxy would need to have already completed an entire cycle of star formation, stellar death, and a second generation of star formation building on those scattered remains, all within roughly the first 300 million years of the universe's existence. Jake Helton, a researcher at Steward Observatory who worked on the galaxy's initial characterization, explained that the specific brightness pattern detected across Webb's instruments pointed towards strong ionized gas emission from both hydrogen and oxygen, and stated plainly that the presence of oxygen this early suggested multiple generations of very massive stars had already lived out their entire lives before this galaxy was even observed. George Reek's team went further, estimating that the galaxy had likely been actively forming stars for a period of roughly 100 million years before the light we're currently observing ever left it, meaning the actual formation of this specific galaxy's first stars would have to have begun astonishingly close to the literal beginning of cosmic time itself. Gergo Popping, an astronomer at the European ALMA Regional Center who wasn't directly involved in either study, offered an assessment that captures the broader significance clearly. He described himself as genuinely surprised by the clarity of the oxygen detection, and stated that the result suggests galaxies are capable of forming considerably more rapidly after the Big Bang than scientists had previously believed possible. That's the exact same underlying tension running through essentially every major early universe discovery Webb has produced since it began operations, galaxies, stars, and now confirmed heavy elements, all showing up dramatically earlier and more developed than the standard model of cosmology, sometimes called lambda CDM, actually predicts they should be able to. It's also worth situating JADE's GS-Z14-0 within the broader wave of similarly unsettling discoveries Webb has produced since it began operating, because this galaxy isn't an isolated anomaly sitting in a vacuum. Separate survey work has uncovered an entire population of unusually bright, unusually massive early galaxies that researchers have informally nicknamed blue monster galaxies, along with a distinct population of small, compact, deeply red objects called little red dots, several of which have turned out to be actively feeding black holes with masses that don't comfortably fit existing models of how black holes are supposed to grow this early in cosmic history. JWST Z14 adds yet another independent thread to that same broader tapestry, an object confirmed through an entirely different observational method, radio detection of oxygen rather than optical or infrared brightness alone, pointing toward the exact same underlying conclusion those other populations have already suggested, that the earliest few hundred million years of the universe's history were considerably more active, more chemically developed, and more efficient at building structure than the standard cosmological model currently accounts for. It's worth being clear about what this specific finding does and doesn't prove, because responsible science reporting requires holding both sides of that distinction honestly. JWST Z14 isn't the only unusually massive or unusually developed galaxy Webb has found sitting inside the first few hundred million years of cosmic history. Researchers using Webb have identified roughly 24 separate galaxies now confirmed at a redshift of around 14, meaning astronomers are observing an entire population of unexpectedly early, unexpectedly developed galaxies, not simply one unusual outlier that might eventually turn out to be a measurement fluke. That distinction matters enormously because a single strange result could plausibly be explained away as an unusual coincidence or a subtle calibration error. An entire growing population of galaxies, independently confirmed using two completely different observational techniques, Webb's infrared imaging alongside ALMA's radio detection of oxygen, pointing toward the same broader conclusion, is a considerably harder pattern to dismiss. That doesn't mean the standard model of cosmology is somehow broken beyond repair. And it's important to say that plainly, rather than overstating the crisis for the sake of a more dramatic story. The broader framework describing the Big Bang, the overall expansion of the universe, and the general timeline of cosmic structure formation remains extremely well supported by an enormous range of independent evidence gathered over decades, including the cosmic microwave background radiation and the observed abundance of light elements throughout the universe. What discoveries like JWST Z14 have actually exposed is a specific, genuine tension in one particular corner of that broader framework. Exactly how efficiently the very first galaxies were able to form stars, and exactly how quickly those first generations of stars were able to live, die, and seed their surroundings with heavier elements in the earliest few hundred million years after the Big Bang specifically. Researchers have proposed a handful of possible explanations to help close that gap, none of which have been definitively confirmed yet. One possibility is that the very earliest generations of stars, sometimes called population 3 stars, may have been considerably more massive and short-lived than typical stars forming in the universe today, burning through their fuel and exploding as supernovae far more quickly, allowing heavier elements like oxygen to accumulate at a pace current models simply don't account for. Another possibility is that early galaxies converted their available gas into stars with a level of efficiency that current simulations underestimate, essentially building stars and the oxygen those stars eventually produce faster than existing computer models allow for. Both explanations remain active, unsettled areas of ongoing research, and neither one requires abandoning the broader Big Bang framework itself, only revising specific assumptions about exactly how efficiently the earliest generations of stars and galaxies actually operated. There's also a responsible note of caution worth including here, because even genuinely exciting, twice-confirmed results like this one aren't necessarily the final word. Reichard Bauwens, an associate professor at Leiden Observatory, involved in the broader research effort, pointed out that while Webb originally discovered the galaxy, it took ALMA's specific capabilities to confirm and precisely determine its enormous distance in the first place. A reminder that discoveries at the absolute edge of what's observable often require multiple independent instruments working together before the scientific community treats a result as fully settled. Continued observations, both of JWST Z14 specifically and of the broader growing population of similarly early, similarly unexpected galaxies, remain necessary before researchers can say with full confidence exactly how this apparent tension between observation and theory ultimately gets resolved. So what does all of this actually add up to? James Webb, working alongside the ALMA Radio Observatory in Chile, confirmed the existence of a fully formed galaxy sitting less than 300 million years after the Big Bang, one already containing roughly 10 times more oxygen than existing cosmological models said should be possible at that point in cosmic history. That single result, replicated independently by two separate research teams, adds to a rapidly growing body of evidence suggesting galaxies in the extremely early universe formed, matured, and seeded their surroundings with heavy elements considerably faster than decades of theoretical modeling had prepared scientists to expect. It doesn't mean our fundamental understanding of the Big Bang is wrong. It means one specific, important piece of that picture, exactly how quickly the very first galaxies came together, still needs real, substantive work to fully explain. And the scientists doing that work are, by their own admission, still finding themselves genuinely astonished by what they keep finding out there. Researchers involved with this discovery have already indicated that further observations of JWST, ZEF 14-0, and similarly distant galaxies remain a priority for both Webb and ALMA going forward, specifically to determine whether the oxygen abundance detected here represents a genuine outlier or a more common feature of galaxies existing at this extraordinarily early point in cosmic history. Given how quickly this particular distance record has already been broken multiple times since Webb began operating, and given how consistently each new record-breaking discovery has turned up unexpectedly mature, chemically developed structures rather than the faint, primitive protogalaxies older models predicted, there's a genuine possibility that whatever galaxy eventually breaks JWST Z14-0's own distance record will simply add one more data point to the same growing pattern, rather than finally revealing the kind of young, undeveloped early universe cosmologists originally expected to find. There's a broader point worth sitting with here, one that extends past this single galaxy and this single detection of oxygen. Every time Webb pushes further back toward the literal beginning of the universe, astronomers have gone in expecting to finally find the quiet, undeveloped early cosmos their models predicted. And every time, they've instead found something that looks considerably further along than it has any right to be. That's not a sign that the people building these cosmological models did sloppy work. Lambda CDM remains, by a wide margin, the best supported description of the universe's overall structure and history that scientists have ever assembled. What discoveries like JWST ZEF 14-0 actually demonstrate is something a little more humbling, that even a genuinely well-tested scientific framework can still be missing real, meaningful pieces at its most extreme edges, and that the only way to find those missing pieces is to keep building instruments capable of looking directly at parts of the universe nobody has ever actually seen before. If stories like this, grounded entirely in real, published research instead of exaggerated headlines, are what you come here for, subscribe to this channel and turn on notifications, because Webb and ALMA are both still watching the earliest reaches of the observable universe, and there's a very real chance the next discovery pushes this mystery even further. Thanks for watching, and I'll see you in the next one.